Launching.
Initiating fixed
Auto arming.
On 3, 1, 2, 3, good. So they're looking good. On 3, 1, 2, and 3. Good.
As part of the greater nps.FX program, in response to SecDef and SecNav calls for more innovation, the initial multi-thread experiment, or MTX, was executed over 2 weeks at the end of 2017. MTX is designed to address the technology gap that exists between current use of unmanned systems and the eventual capability of these systems to support the warfighter in a fully autonomous mode. MTX explores the ability of multi-domain network control systems to enhance mission performance using autonomy.
What we're trying to do is create a network control system and understand how to control that system with fewer people. I call that a tooth-to-tail ratio. What we're trying to do is reduce the number of people that's required to operate more vehicles. And what we're also trying to do is create autonomy within that system so that there are algorithms that are on board that are trying to understand what is the best position, for example, to communicate information in an optimal fashion. So the mission scenario that we've developed focuses around naval special warfare, a small element. And one of the fundamental things is that can we use unmanned systems to reduce the number of personnel that are required to go in and do a direct action mission at an objective. So in this case, what we're talking about is that through the phases, there's several different ones, typically with a military operation. It's insertion, infiltration, actions at the objective, exfil, and extraction. So in insertion, what we're talking about even before insertion is intelligence preparation of the battle space. So for the undersea domain, what that means is that we send in a couple of REMUS vehicles that are navigating relative to the ocean floor and collecting sonar information, forward-looking sonar, side-scan sonar, other oceanographic information. And that's used to determine where is the best position to bring the SEALs ashore. Once that's obtained, then that information is translated over to the SEALs that are on board an unmanned surface vehicle.
So CFOX is an unmanned boat, essentially. It's a fully autonomous robotic vehicle. For this experiment, they have become mobile wireless nodes on our mesh network, and they will be serving in the maritime domain to relay messages from underwater vehicles to aerial vehicles.
That unmanned surface vehicle is then deployed over to do over-the-beach horizon operations. That brings the SEALs ashore. While we're doing that, we have an overwatch, a communications link.
ScanEagle is a military UAS aircraft. It's an unmanned aerial system. For the experiment, it's a mobile aerial node in the multi-thread experiment for the testing of the network control system.
Now the SEALs are transitioning from an insertion to an infiltration. And now they're transiting up to the actions at the objective. So the ScanEagle and the CFOX are both acting as communications relays and also as sensor platforms to support their mission area. Now with the multiple ScanEagles, we can also have digital video transmitted to the SEALs as they're transiting to be able to let them know what's happening at the objective area. Also, in a future vision, they're allowed to control one or more of the ScanEagles from the ground. So the rest of the system, the networked control system, then adapts to make sure that it's got good communications and sensing capability back to their command and control, which in this case is an offshore ship. The other aspect is the outstanding job that the network folks have done in putting up a backbone network and also the aerial network. A lot of work went into that, and also the tools, and that's associated with the Synetics lab at NPS.
The role of our team is to bring and implement expertise in putting together self-forming mesh networks to integrate unmanned systems, vessels, and dismounted operators into a seamless network infrastructure and to operate it. So based on that, we've established the backbone, fixed architecture across the island, helped to connect most of the unmanned assets.
I spent about 5 days on San Clemente Island and gained a lot of exposure to the unmanned assets that the Navy is currently implementing into its arsenal.
I wanted to participate in the multi-thread experiment because I wanted to be able to take the information that we're learning here at school and apply it in a real-world scenario.
And I found it very encouraging and enlightening to see where the Navy is headed, and it also provided a perfect case study for which I can frame my thesis in.
As an information professional, getting hands-on experience with cutting-edge technologies will help me in the future to employ those technologies when they come about to the Navy as a whole.
It's what the team has done has exceeded my expectations. I was concerned about the different vehicles and transitioning through the different phases. All of our principals in the different domains, the person that was the group from NEDU that was running the underwater vehicles, came up to speed very, very quickly and have done a great job. Likewise, the CFOX folks have done an awful lot of work, Dr. Sean Cragling specifically, and then the team from ScanEagle have presented the opportunity to do better experimentation than I had originally anticipated.
The SECNAV-directed, ONR-funded Consortium for Robotics and Unmanned Systems Education and Research, or CRUISER, has been the primary sponsor of the MTX and underlying research efforts. The Office of the Secretary of Defense's Rapid Reaction Technology Office was the key sponsor of this initial MTX experiment. Among the many partners integral to the success of the current MTX effort are SPA War Systems Center Pacific, Commander, U.S. 3rd Fleet, Commander, Naval Surface Force Pacific, San Clemente Island Staff, FACSFAC, Southern California Offshore Range, and Navy Experimental Diving Unit. Thanks to all who supported this initial MTX effort, the team has learned enough to take the next step toward employing autonomy in the battle space to enhance mission performance.